Assalamualaikum warahmatullahi wabarakatuh. Today we are going to go further into automation in manufacturing part 2, which is in this lecture we are going to see more advancement of automation in manufacturing system. So in previous lecture we have delved into the details of implementing automation in manufacturing. We have seen why we need automation in manufacturing in terms of worker and the product, and what are the strategies of process improvement and automation, as well as how to implement them. We have learned that there are 3 types of automation that can be implemented, and the order goes from the fixed to the advanced flexible automation. We have also seen the influence of production quantity and production variety to the type of automation that can take place. And we have also learned that the level of automation that can take place is not limited at the process level only, but also can be implemented up to the enterprise level. We have seen how this can be done through the concept of computer aided manufacturing, which is the essence of the flexible automation. Therefore, in this lecture, we will go further to more advanced automation solution. But what can be more advanced than the flexible automation in manufacturing system? So here comes the terms cyber physical system. It is the essence of the 4th industrial revolution in manufacturing. So we will go through the challenges for manufacturing in 4th industrial revolution, what is actually a cyber physical system, and we will see one of the model later on of how the cyber physical system can be implemented in practice. So if we will not probably have the time to see the model today, but I will do it probably next week. Okay. So in previous lecture, I have touched a bit on the Industrial Revolution. The first phase of Industrial Revolution actually happened from the year 1784, which was mechanical production on the basis of water and steam. The second Industrial Revolution happened at the beginning of the 20th century during the introductions of conveyor belts and mass production. The third revolution takes place in the digital automation of production by means of electronics and information technology system. So in this 4th revolution, automation now becomes ubiquitous, and instead of focusing on simply automating the production, it evolves into cyber physical system in which customization can be done on the fly with optimized decision making in place. The production now becomes more productive, flexible, versatile, safer, and collaborative, thus creating an unprecedented level of value in the entire ecosystem. So smart factories, which will be at the heart of Industry 4.0, will take on board information and communication technology, an evolution in the supply chain and production line that brings a much higher level of both automation and digitalization. So it means machines using self-optimization, self-configuration, and even artificial intelligence to complete complex tasks in order to deliver vastly superior cost efficiencies and better quality of goods or services. Now, from the manufacturing point of view, the 4th revolution shifts the paradigm of using automation to mass-produce goods into mass customizing goods. We have learned that ideally we wanted to have more flexibility on the manufacturing side through flexible automation system. But we know that flexible automation is still pre-programmed. Therefore, it has a difficulty reaching the requirements of flexibility, adaptability, and reliability of a product manufacturing as the exclusive and individualized demand kicks in. So the mass customization that we foresee happening means that the product itself will have shorter product cycle, customized, but with lower price and best quality. So the industrial manufacturing life cycle becomes orientated towards increasing individualism of customer requirements. It emphasizes the idea of consistent digitalization and linking of all productive units in the production system. So therefore, the manufacturing system in this fourth industrial revolution is aimed to be well adapted to manufacturing changes due to the mass customization that will take place. So this trend requires manufacturing system to have the ability to adapt to fast change of the manufacturing environment. To face these challenges, the new trend of manufacturing system development is to apply autonomous behaviors inspired from living systems and nature to have sustainable manufacturing system. So the manufacturing industry in this era 4.0, is characterized by autonomous system. Okay, autonomous system means the system that is on their own, make decisions, and then act accordingly. So it is a cyber and physical representation and advance in ICT. So you have advancement in ICT such as cloud computing, Internet of Things, Internet of Services, agent technology, cognitive technology, big data, data mining, and artificial intelligence. In other words, Industry 4.0 is the new era where the Internet of Things alongside cyber-physical systems interconnect in a way where the combination of software, sensor, processor, and communication technology plays a huge role for making things. So it is quite prudent to say that the term cyber-physical system is simply used to describe the system that connected the physical world with the digital. So it can be considered as a confluence of embedded system, real-time system, distributed sensor system and controls, which focus on complex interdependencies and integration between cyberspace and physical world, and composed of tightly integrated computation, communication, control, and physical elements. So if we can see that this definition of cyber-physical systems include a lot of jargons that have basically the elements inside the cyber-physical system is that we are trying to make sure that the system itself are smart enough to make decision on its own and then probably have the ability to predict what it can do, what it cannot do, and then the ability to communicate the decision making as well as the actions during the process. So a CPS itself is autonomous and have intelligent behaviors. For example, the use of IoT. Okay, so IoT actually involve devices which are connected and are smart enough to communicate with each other. So the IoT itself enables things around you to send information over the internet. So sensors typically send gigabytes of data in an hour, for example. And the real challenge is to store, manage, and derive value from this sensors data. So big data technologies will help in storing the unstructured data, process it, and deduce insight valuable for business purposes. And inside this thing comes the cognitive agent technology, which enables the realization of autonomous behaviors such as perception and action, and intelligent behaviors such as learning and reasoning to make a decision that are carried out by using artificial intelligence.